This is Linux In-Laws, a podcast on free Libre open source software, broadcasting from the United Kingdom and Germany.
Welcome to Linux In-Laws, Season 2, Episode 58. Martin, how are things today?
Yeah, snowy, but good, thanks.
Snow in the UK, why?
Falls out the sky.
Why?
Because of the temperature. and the temperature and the moisture, that's usually how snow is made, I believe.
It's a rare occurrence.
If you paid attention in your at school, you would have known this. But
it's a rare occurrence in the UK, is it not? No?
It doesn't happen in the summer, no. That's
fair enough.
What about you? Do you have any cold weather over there?
We do.
Probably. You do?
Yes.
Okay.
Courtesy of Russia and other geographies, I suppose.
Oh, isn't that because they took the gas away again or something? No?
No, Martin.
No, it's the oil. The oil.
That's prior to the war.
It's the Americans who took the oil, yes.
You're getting confused, Martin.
No. The Americans confiscated an oil tanker that was meant for Russia or something. Anyway,
they did. Okay, fair enough.
Did, because they also captured the president.
Did they now?
And by the time of this recording, they'll also captured Greenland.
We're recording. We're recording this
and
in
Denmark.
This is another time. Exactly. This is another time traveling episode.
Yep.
Recording this in January of 2038. Okay. The good news is basically that Martin is talking about... Yeah, and you don't want to know, Martin. The good news is basically Martin is talking about historic events. You see, in 2026, Trump, that idiot, aka known as, made an attempt to conquer Greenland, Venezuela, and some other countries. But because of the following midterms, he blatantly failed. He was ousted, and before the year was over, all was returned to a normal state. That's the good news.
Sounds like an alternate reality to me.
This might just look at the history books, but this is not a podcast about time traveling or history. This is a podcast about floss as in free Libre open source software. So, Martin, what's tonight's subject then?
No, subject is something to do with music.
Is it now?
Yes. Well, music media like records and CDs, all that kind of stuff.
We tentatively titled the episode as CI/CD. I get
there's a CI. Yes. I don't know that format.
What is CI now in any music context? I wonder.
That's a good question. Compact.
I mean, CD stands for crystal dust. No.
No, it stands for compact disc.
This is basically
probably after your time.
Exactly, kids. This goes to show how old Martin really is, because he knows these terms and I don't.
You're stuck in the cassette tapes era.
What are cassettes, Martin? Okay.
Anyway, yeah.
No, of course, the CI/CD stands for continuous integration and continuous development. So for the two people in the audience who do not know what that means, Martin, why don't you enlighten us?
Well, so when was this? Probably
in the 80s?
No. So, okay, let's start at the beginning. So applications used to be built in a monolithic way by teams of people spending months and years designing them and then building them over the next few years. And so that was all very slow.
Martin is talking about his teenage years, of course. We're talking about the 70s and 80s.
Yes.
But things do have progressed, Martin.
Things have progressed indeed, yes. So what happened was that the iPhone came along, as well as, I think probably the iPhone was the trigger for this, because they had something called the App Store. Which came with apps, and people liked apps. So the thing was with apps was that people have a short attention span, and after a few weeks, they got bored with their apps. So then some clever people thought, hang on, if we keep pushing out updates to these apps, people will keep using them.
Yes!
Which was, in fact, true and proven. So yeah, this is where the whole continuous development thing came from. And
so mobiles are to blame. Is that what I'm hearing?
Yeah, well, so that was the start, right? But then after that, people thought, oh, hang on a minute, our banking app on a website also needs to be updated every 2 weeks because then we can add new features and people spend more money with us and so on. So yeah, the mobile era was kind of the start, but then it also moved into more mainstream apps, right, and web-based things and so on.
I mean, there's a rumor out there that Amazon deploys on a per second basis, meaning that they push out new builds every single second for selected geographies.
Yeah,
and then try this out, get the feedback, collect the feedback on an automatic basis, and then modify the code base accordingly. So the idea, and Martin got this spot on, by the way, the idea is to fail quickly and to get immediate and instant feedback from any new features that you push into your builds.
Yeah, the actual, as you say, the code has telemetry built in to see what of it's actually used and how much, and how long people spend on certain things, right, on certain pages or parts of apps and so on, so they can decide what's good and not in their app.
And before we go further, we should probably slightly elaborate on how software was built before that, because methodologies like the V model and afterwards waterfall comes to mind. Exactly.
Yeah.
So in the olden days, basically people sat down and wrote down the requirements. Then a business Then a business analyst or some similar function would take a look at it, translate this into an architecture, and then an architecture would take a look at it and translate that into a high-level code base, which then engineers would get down to implement the whole thing. Then QA would kick in, if you're lucky, would test the whole thing for a couple of years, and before you know it, as in between 5 and 10 years, the new code base, including all the new features, functionalities, and bells, and whistles, of course, would be ready.
Yep.
Some people disagree subsequently with that notion and said we need this not in a 5 to 10 years time basis, but rather now. And as Martin has rightly pointed out, has pointed out, you can only achieve this, and the iPhone is probably the best example for this, if you change your approach, hence this agile thing and backlogs and sprints and all the rest of it.
Yep.
So, but apart from changing this methodology, you also basically have to change your approach. So rather than sitting down for a couple of years, implementing the code base, testing this, and then finally deploying this again in the time span of a few years, you do this more or less instantly. And that's exactly where this continuous integration and continuous deployment comes from. As in, you write a little piece of code, you push this into your tool chain, into your build chain, and then a whole slew of automating takes care of testing this. First of all, of building this, of testing this, and then deploying this into production. Hence the notion of continuous integration, continuous deployment, rather, not development. And I already mentioned the components, basically. So if you...
Yeah, I mean, I was going to say, there's the automation of the whole process, but it also gave kind of rise to the Dockers of the world and stuff, right? Because that made the whole... deployment of code in production much simpler by just deploying a container rather than a piece of code with all its dependencies and so on and so on.
Martin, of course, is referring to a prepackaged user land in technical terms, living in the so-called container, which is an abstraction of an operating system, let's put it this way, where many containers can share a single instance of a kernel from a technical perspective, i.e. the beauty is, and this is probably not a well-known fact, that containers are also about resource sharing, but at the end of the day, it's about packaging, i.e. what goes into your image.
That's where the name came from, right?
Exactly.
Shove it all in a container.
Exactly. What goes into your image, and of course a container is an instantiation of an image, as in the image is a pre-packaged user land running on a kernel, and then you have a pretty much well-defined user land at your disposal with the exact version of a database, with the exact version of a messaging system like RabbitMQ, with the exact version of your database and all the rest of it. And this is basically the second advantage of a container technology being basically put into production. We'll touch upon this in about 7 hours, 45 minutes when we'll talk about Kubernetes. So stay tuned. Yeah. Don't fast forward, exactly. Because there will be some stuff that we're going to cover in between. So let's take a look at how your tool chain, as in how your workflow.
Yes, before you do that, you missed that one buzzword, right?
Did I now?
You did. No?
Which is Martin?
Cloud native?
Yes, but we're going to cover that in the container discussion.
10 hours.
Exactly.
All right, fine. Yeah.
Okay, so let's
For
take
those
a
of
look
you
at
doing
basically...
the bingo, there we go. Yeah,
exactly. So if you haven't fallen asleep yet, don't fast forward, just listen. Fair enough. Cloud native, it will be covered soon when we touch about containers and other fun facts.
Excellent.
Okay, let's take a look at how you actually build software.
Okay.
You have this bright idea, and then you sit down and write code. We already kind of covered the V model angle and the waterfall and all the rest of it. But at the end of the day, you take a business requirement.
You've got a few steps missing there, really.
Martin, fill us in.
Well, you started from idea to writing code, and
yes,
normally many things happen in between.
This is called agile now.
Okay. Well, I thought you meant prototyping.
No, Martin, why don't you fill us in on the olden ways of writing software?
Well, you already kind of described that a moment ago, right? So it's, as you said, gathering requirements, designing, etc.
Now, Martin, being the hipster type, of course, thinks about things like MVPs, minimal viable products, that are basically a proof of concept as a POC that actually go to show that you can implement what you think about.
Yeah. I mean, you've probably all seen the, I don't know, what do you call it, the picture of the evolving bicycle into a Ferrari or whatever it is, right? That's what MVPs are normally about. But there is an alternative version of that as well, which is...
Yes, it's called Windows, if I recall.
No. It's where an MVP is just the wheels and you can't actually do anything with it. A bicycle.
I thought Windows was the longest lived MVP on the planet, as in for the last, 25 years or something? Maybe 30 years.
Could be.
I mean, it looks like that from the outside, because every time I use Windows, which I rarely do... Yes, I rarely do this.
How come? What happened?
That's actually a very good question, Martin.
Are you ill?
Maybe. No, I mean, every time I look at it, and this is now 2 seconds of Microsoft bashing, I still have the impression that I'm looking at an MVP. But going back to much more serious grounds, the idea is basically to test things out fairly fast, fairly quickly, and this is what this whole agile thing is all about.
Well, that's not as in actual testing, right? This is just throwing it over the fence to some users and seeing what they think.
Yes,
rather than proper testing.
Fail quickly, fail fast, but it all ties in.
You still want to do some proper testing before you actually give it to someone, but
do you know? Okay, Microsoft, if you're listening. In case, okay. So going back to the tools, going back to the workflow, you take a piece of code, you put into your versioning system, and then what?
Well, it depends what you set up, right?
Indeed.
At some point, it wants to make it to production, and the way you do that depends on what you set up.
Normally, actually, you would at least perform some sort of unit testing, i.e., you would test a newly added feature on a per unit basis so that you know what it's doing. Because normally a QA cycle is broken down into 3 parts, as in unit testing, integration testing, and user acceptance testing. But before you do this,
what about performance testing? Okay,
that's a non-functional part. We're going to come to that in a minute.
In a minute? Surely in a few hours. Anyway, carry on.
No, and already Martin kind of rightly touched upon non-functional testing. That means how is the software reacting to failures? How is the software reacting to scalability requirements? I.e., if you sit down with a banking app,
and it's 5 million other people do the same thing.
Exactly. If there's only one user, that's fine. But what happens if 5 million people do the very same?
Mm-hmm.
And what happens if you pull the plug? As a network plug, power plug, and all the rest of it, does the software break down, or is it actually resilient enough to survive a temporary glitch, a durable crash, or whatever, in terms of how is the software surviving? Does it?
If it's crashed, it hasn't survived, right?
Exactly. But before it crashes, basically, it might have the possibility of preserving the system state in a persistent way.
Oh, that's what databases are for. Anyway, carry on.
Exactly. But that's only one component of resilience. So, for example, Kubernetes.
Kubernetes. Oh my God. Yes. Oh no, you're too early. We got a few hours.
No. just hear me out. Martin, Kubernetes is just one example because Kubernetes is actually able to measure or to observe the state or the health of application, and if applications rather.
Health of the pod, right? Not the application itself, but
well, the application software running inside the pod, which is pretty much the application. But not to worry about this. And if the application is misbehaving, it simply restarts the pod, as in the entity where the Kubernetes is running in. So this is a very basic example of bred in application resilience. But before we touch on the Hipster stuff, let's take a look at the actual tool chain, as in what happens basically in the workflow. Now, if you've written your code, you've then triggered a build. Then QA kicks in, and the QA is under the impression that yes, the software is worth releasing, so you deploy it.
Yeah.
And then the software runs, and then the user can use it.
Okay.
And then all hell breaks loose, maybe.
Well, it depends, but anyway. Yeah. Okay.
Okay, there are a couple of scenarios here. I mean, you can, for example, you can do it on your own server, as in where only a few users can use the software, or much more realistic these days, you do it in a so-called cloud environment, as in other people's computers. And this is actually where the fun starts. Because all of the cloud environments have their different ideas of deploying things.
Well, unless you use Kubernetes or stuff like that.
Kubernetes would be the kind of the basic standard across clouds.
Indeed.
But even AKS, which is used by, I think, Microsoft, EKS, used by or offered by AWS as in the bookshop, and GCP as Google has something similar. They all have their differences. As in they have the different APIs, they have their different semantics. No,
you can always run your own in cloud as well.
Exactly. So you could set up a couple of VMs, but you would have to deploy these VMs prior to using them. Yes. So you have to specify what operating system goes onto them, what middleware is deployed in these VMs, and all the rest of it. This is where the fun starts, right?
Well, that's what IT departments are for.
Exactly. So IT departments, if you're listening, here's a little recipe of how to do your job better. Come tomorrow morning once you've listened to the podcast.
Excellent.
No, I'm joking. Okay, so for want of a better picture, I mean, what's what I'm looking for? Let's take a look at how this is done in reality in terms of how you would integrate this into your existing workflow. For example, let's imagine you would use a versioning system like Git based on GitLab, based on Git, GitHub, or even GitLab. All of these versioning systems offer so-called webhooks. Or hooks rather, that allow you basically to trigger a certain set of actions once you merge, once you check in something or once you accept a merge request.
Mm-hmm.
And then you can basically specify the sequence of actions that will take place once you've done this. So, for example, you would trigger build, then this build would be subjected to an automated sequence of quality assurance steps. And if this workflow would then deem the code base fit for production after a so-called smoke test, i.e. it starts up the software and the software doesn't fail immediately, it would basically say, no, look, this is okay. Either put it into a staging environment where further QA would take place as in quality assurance, or let's release this in production right away, and then it's good to go.
No, I mean, this is how most people set it up. Indeed, yes.
Indeed. Once you've done this, the software's out there, ready to be used by the innocent user.
Mm-hmm.
And then what?
Well, then they, as we discussed at the beginning, then feedback comes in one way or another, and or people deal with stuff that they have in the backlog to trigger the next release or build the next release. Right?
So once
continuous.
Exactly. So once you hit this kind of feedback button and you then type in the magic word, this release is crap, what happens then?
Well, what happens then? They have a stand-up.
Yes. And somebody will get shot. Maybe not.
What's the other thing they do? A retrospective. Sorry, that's it. Yeah.
They would do a post-sprint appraisal. Yes, Martin. Of what went wrong and what didn't.
Why don't you enlighten the audience on the hipster terms? Yeah.
Okay, the hipster terms would be agile, for whatever, and what's what I'm looking for? The methodology is called. I'm blanking now.
Oh, okay.
Scrum, of course. Yes.
Yes.
Scrum. Scrum basically means that you develop software in a hipster way. I'm simplifying things, of course, in terms of you have a backlog that defines the scope of the current implementation phase, which is called sprint. Then you would have a product owner that controls the backlog, as in representing the business, just basically to fill some gaps here. And a Scrum Master who supervises the whole thing, and you would then have this team, the Scrum team, that would take care of implementing the software, designing the software, documenting the software, testing the software, and all the rest of the beautiful tasks associated with your software development lifecycle, as in the SDLC.
Mm-hmm.
Typically, sprints vary between a day and 7 years. Sprint teams can be between 2 and 7,000 people, maybe. No, I mean, typically, to be much more serious, typically sprints are anything between a fortnight and a month, and your average Scrum team size is roughly 7 people plus minus, maybe 2 or 3 people. Let's give or take a few, and that's it. Plus the Scrum Master, plus the product owner, and all the rest of it. The other artifacts do not change, though, because you would normally have, after the end of the sprint, you would have a post-sprint appraisal, as in terms of where you would sit down and then basically discuss what happened during the sprint and what didn't go well or according to plan.
Yeah.
The idea is basically because you only have very short sprints in terms of in comparison to the other models, you don't have 7 to 10 years to develop the software, but you break this down into way shorter cycles called sprints. The idea is basically, if you take the wrong turn, that you notice this very quickly and then can take immediate action in terms of correct your mistakes. Let's put it this way.
Mm-hmm.
That's the overall idea. So you're much more reactive in comparison to the waterfall at the V models of the world.
Mm-hmm. What's this V stand for anyway?
Links within the show notes. It's an engineering software methodology going back, I think, to the 80s or 70s.
It's pre-waterfall, is it? Okay.
Yes, it's pre-waterfall, where essentially you converge on an angle point with the requirements and the implementations. Basically, you sit down, you elaborate on the requirements, you flesh them out, and then at the very pinpoint of the V, of the letter V, you would actually start the design and the implementation. So it's kind of a picture of how to develop software. I think that's where it comes from originally.
Okay.
But going back to much more interesting things, the tool chains typically associated with CIs and CD. And the tool chains, of course, can be broken down into two parts: pre-cloud and cloud-based, as in the Hipster stuff.
Well, surely cloud is just the deployment model. Anyway, yeah.
Yes, Martin, it is, but
anyway,
with a set deployment model, there are a few technologies that normally hipsters use these days to deploy software.
Bash, isn't it?
No, Martin. This is pre-cloud days. I mean, clouds I would typically associate with either virtual machines and, much more importantly, containers.
Okay.
As in the Kubernetes of the world. Because this is basically I'm unsure about the exact deployment rate, but I reckon a guesstimate would be that any software beyond a certain size in terms of user base, and we're not talking about 2 or 3 users, we're talking about 10 plus, maybe 100 plus users, would be deployed as Kubernetes controlled containers these days, or pods as they're called. So because of scalability requirements and resilience and all the rest of it, because Kubernetes essentially is the orchestration framework of choice for such deployments.
Yeah, it appears to be.
So, Martin, let's go back to the pre-cloud days. Let me hand it over to you because you're way older than I am.
Pre-cloud days.
I wish that was the case. Yes, Martin. Remember the 60s. We're talking mainframes. We're talking about punch reader cards. We're talking about tapes.
Okay.
We're talking about, JCL and all the rest of it. How would you do CI/CD then?
Well, the fundamentals are the same. It just takes longer.
Yes, Martin. Enlighten us. What happened when you first sat down in front of PDP-11 all those years ago?
You'd have to hand the code over to someone, and then someone had to put it on a tape, and the tape had to be run on something, and so on and so on. So it's the same idea. It's just slower.
This is what Martin means by bash, I suppose,
and less automated.
Exactly. No, I mean pre-cloud that would be basically you would have your Jenkins, because Jenkins is one of the most prevalent, I reckon, legacy CI tools. Jenkins, in terms of being,
I wonder why. Why is it legacy?
Because it's written in Java.
Okay.
Yes, Martin, it is.
That makes a lot of sense. Yeah.
Yes, Jenkins would basically implement a plugin-based workflow for software integration, as in builds and deployment. Back in the olden days, Jenkins has plugins for everything under the sun. I think it also defines something called runners that implement these workflows once a certain action takes place. So let's take a look at how modern CI/CD pipelines work. You check into something into your...
Wait. What's a modern one?
A modern one, for example, would be Argo, Tecton, something like that, or even the Git-like versioning systems.
Okay. What about Flux? Is that a modern one?
Flux, enlighten me. Yeah, probably it is, yes. I've heard the name, but I wouldn't say I'm an expert on this. Flux, I reckon, is comparable to Argo or Tecton, which we're going to touch upon in a minute. Okay, you check out a piece of code, and then this workflow kicks in automatically, as in checks out a build, as in tries to build the software, runs a couple of tests, and then if the workflow deems the software worth deployable, it maybe pushes into a staging environment, or it pushes into production. This is the case across all of these tool chains. Jenkins, Argo, Tecton, you name it. Argo, Tecton, and Prebag, which is essentially a what's what I'm looking for, amalgamation of cloud-based workflow components, they all work similar ways. Even the webhooks of GTA, Gox, and all you name it, and all the rest of them work in similar ways. I.e., you check something and then the workflow kicks in. Jenkins actually has plugins to observe that sort of thing. In terms of if you check a piece of code into your versioning system, Jenkins will notice this and kick off the workflow. There's also a cloud-based version of Jenkins called Jenkins X, which is similar to the likes of Tecton and Argo, which are purely, by the way, Kubernetes-based tools. Jenkins is much more comprehensible, as in Jenkins X is much more comprehensible, and it's just not aimed at Kubernetes alone. But given the fact that Kubernetes has captured much of the market, the likes of Argo and Tecton basically are on the way up with regards to Kubernetes-based deployments. So, for example,
why do you need these things when things like GitHub Actions can do all these things for you?
GitHub Actions does not know how to talk to Kubernetes out of the box. You have to teach it. So we should explain what GitHub Actions are.
Just have a script to deploy a YAML. There you go.
Yes, exactly, Martin. So
kubectl apply. There you go. It's done.
Yes, but why sit down and do that yourself if somebody has already done this for you? So before we go further, we should probably explain what GitHub Actions are, Martin.
Okay, go on then.
GitHub Actions are essentially a YAML-based definitions of actions that take place once you commit something to GitHub repository.
Mm-hmm.
And then anything as offered by GitHub takes place. The thing is that this whole thing is plugin based, but
they're all plugin based, no?
Yes, but GitHub out of the box does not know how to talk to your, for example, Kubernetes deployment.
Right, it's the right script to do, as I said, kubectl apply.
So exactly, so you have to sit down and reinvent the wheel all over again.
Well, but yes and no, because you have to specify your YAML anyway for your. You have to have a version of your application YAML defined, otherwise you can't deploy it without that anyway. So, and the tool is not going to write that for you. You'd have to specify in the first place.
No, but with the likes of Argon, which is basically kind of really simple and basic, you just point it at the GitHub repo and point it at your Kubernetes deployment, and then Argo, and with much more comfort, Tecton does pretty much the same, but Tecton offers much more functionality. Links, of course, will be in the show notes. These tools are actually able to watch any CVS, ideally Git-based, and then take care of synchronizing the code versioning system with the Kubernetes deployment. Whereas with GitHub Actions, you would have to do that yourself. They do it for you with regards to Kubernetes-based deployments. This is the major difference between.
Yeah, but I still don't see how they can deploy your application without knowing the parameters and how many and all that kind of stuff and where and the sizes. You can't just. You have to specify these things anyway, right? It's just sounds like a fancy interface to YAML to me. If you're listening, Argo people.
No, I mean, without going into the details, they define something called custom resource definitions.
Well, yeah, but again, you have to fill those in. They don't just come out of thin air. Right?
No, but they have done the groundwork for you, Martin. That's the beauty about it.
Okay.
So you simply take these CRD definitions and fill them with kind of your exact deployment details, rather than rewriting them for the GitHub Actions, because this is basically what these two tools save you from. So they lessen the complexity of your deployment.
Yeah, it's like a fancy UI, right? It's like.
It's much more than that. Let's not kind of go into the details because
we will lose the last. Guy, anyway. Clearly, I was wrong.
Before we lose the last listener, because he or she may have fallen asleep about 20 minutes ago. No, I'm joking. Details will in the show notes, but let's not dive into the technical details because in that case, this episode will be rather 4 hours long.
Mm.
Again, most of these would be cloud-based, but of course you can also do this with kind of virtual machines that you control yourself.
Or even bare metal.
Of course, yes.
Anyway. Yeah, okay.
Oh, Martin.
That's good.
What's wrong with bare metal then?
What's wrong with it?
Yes.
Nothing. It's great.
I thought it would rust or something.
I suppose if you don't put any paint on it. Yeah, fair enough. Yeah,
so you have to paint it. You have to look after it. You probably have to feed it too. And maybe the power consumption would be higher than clouds, no?
No.
No, of course. Okay.
No, the cloud is also a computer. It's just someone else.
Yes, man.
They also have to use power. It's just you're not seeing the power bill immediately.
Yes, but somebody else pays for the power, right? So, yes. Okay.
Yes. Well, no, you're paying for the power, obviously, when you...
Yes, but not directly. You do this indirectly.
Indeed.
That's the beauty, exactly.
Yes.
Exactly.
Yes.
So...
No, it depends. Anyway, carry on.
What about security, Martin?
Yes, indeed. Well, if you automate all this stuff, then what is there to stop malicious people from injecting something into your production?
That nicely leads us to to a future episode on the software supply chain aspects and S-bombs as a software bills of material.
Uh-huh.
That's another 4 hours.
Oh, okay.
Hopefully this year, maybe next year, depending.
Fair enough.
Well, all will be explained. No, jokes aside, the idea is basically to control what goes into your bills. Simple as that. And there's also support in terms of, for example, a component called SonarCube that allows you basically to control certain aspects of your software supply chain, but is more aimed at software testing as such. Basically, SonarCube is able, also plugin based, for example, to analyze the attack surface of a code base, like detecting smells, detecting glitches, detecting any other errors that might be inherent in your not just code base but also supply chain where your code base is resting on.
What about social engineering? Can it identify that as well?
No, it can't, because that's a human factor. We're still talking about computers, no?
Well, yes. Well, but that's obviously quite a big risk, right, in all spaces. So. Anyway.
Yes, but I have yet to see the SonarCube plugin, basically, that is able to identify a malicious phone call.
Well, there you go.
So people,
if you got if you're listening,
tonight, exactly. If you have a few hours to spare,
can't be that hard. Yeah.
Yes, the URL might be in the show notes. So why don't you just sit down and write this SonarCube plugin that is able to take a phone call and to give you back a confidence interval if this phone call was actually malicious or not.
Indeed.
And here's a thought. If you do this well, just do a basic version that basically just picks up the phone and just tries to listen and watches out for some catchphrases, and then gives you back a confidence interval. But the enterprise version, of course, can be able to do
version. What
exactly?
It's open source.
Yes, but if you're going for an open core model, the enterprise version tightly integrates with your SSO and all the rest of it. Exactly. And you're off to the races.
Any chance?
No, Mark. No. I'm just making things up as I go along. So the enterprise version basically will make you a millionaire in a few clicks or something. I don't know. I'm just joking. Anyway, okay. But there's more to security.
Yeah, we could probably do that. Yeah. Okay. Fair enough. We should cover that in the future episode. Sounds like a good plan. What about this cloud business then you wanted to talk about?
I already did this. It's Kubernetes and friends.
Oh, okay.
Or is there more to clouds these days than Kubernetes and containers, I wonder?
Well, there's always serverless, but hey, let's skip that.
Martin, what is serverless then?
Well, serverless is where you don't get your own virtual machine. You just get an endpoint which is running on a machine shared with other people and stuff like that, where you don't have access to
how does serverless differ from containers, I wonder?
Well, it's just a different name, right? I mean, serverless doesn't have to be implemented as a container, right? It could be,
if we take a look at how hyperscalers implement,
in theory, a VM, right? As long as you don't have access to it, it's serverless.
Of course, there was an episode on Bottle Rocket. Links, of course, will be in the show notes. Yes, which is an AWS project aimed at serverless. In terms of it's a tiny Linux kernel executing amended by Rust code, aimed at executing lambdas, essentially. Lambdas, of course, being the serverless offering that AWS is raging about, as in the bookshop. So at the end of the day, you're looking at predefined containers that are kind of ready to run in terms of have a predefined workload, that are just waiting for snippets of code to enter this container and then to be executed, hence the name serverless, and you get returned the result of the computation. That's serverless for you in terms of essentially it's a couple of containers with a predefined workload running on a VM.
Yeah, I mean, you're thinking a little bit more about Lambda, but there's also serverless offerings of your Redis's and all that kind of stuff as well, right?
The exact difference being what?
Well, in fact, the difference being that it's not just a Lambda function where you put something in, it runs and it comes out, and then the Lambda function is dead.
Full disclosure, Martin is talking about a concept called marketing. that he's most familiar with because he keeps firing Linux in-house marketing department.
Indeed.
Once I hire them. So you're talking about
this is why we still have the same name, Otherwise we would have been renamed about 5 times by now.
So people, if you're listening, don't worry about the finer details. Essentially, just keep in mind Lambda serverless all the same from a technical perspective. Yeah. The rest is blatant marketing. Don't worry about it. Hyperscalers, if you're listening, we don't have any money, so forget about suing us. Okay, before we round this off, Martin, the future.
Ooh, interesting.
Yes, the future, as in what's going to happen next in the CI/CD space.
Well, there is a whole kind of movement. I don't know if that's the right word. But there is something that's come around in the last few years called green DevOps, right?
Yes. What is green DevOps?
Well, it's DevOps in the jungle. No.
Excellent. Continue.
Well, this is where you plonk you plonk your Scrum team in the jungle, and they don't get out until they finish the code.
Don't forget praying just in case.
Indeed.
No, of course, what Martin is referring to, it's a carbon-aware pipeline. So, Martin, what's a carbon-aware pipeline?
Well, this is where, it's really about, on a serious note, on the energy consumption of the CI/CD pipeline, right?
And how do we implement this then?
How do we implement this?
Yes. I mean, it's fair enough, it's a marketing term, but what is under the hood if you're talking about green ops or carbon or the carbon-aware CI/CD pipeline?
Well, how do you implement this? You can reduce the number of builds, right? I mean, obviously, builds take computing power, and thus electricity. What else can you do? Using small infrastructure to build this stuff, or serverless, as we just talked about.
In case your software complies, yes, indeed.
And then, just making things more efficient rather than throwing, as you know, with any piece of code, you can write it in many different ways. And so some ways use a lot of computing power, some other ways use less, and can be the same result.
Another term, of course, is intelligent scheduling, where actually you postpone the heavy duty task, as in the energy intensive tasks, to a later point in time and prioritize QA cycles in favor of the heavy stuff. But that neatly aligns with something called the artificial intelligence approach, where actually some AI takes a look at the code base first and then decides what's heavy and what isn't.
Yeah, I mean, I know you don't like all the code assistants and stuff like that, but I guess in some years' time, they will actually be quite useful in that respect, that they can also identify more efficient code as well, right? So therefore reducing the energy footprint of all this stuff.
Yes, another trend, if we're on the prediction topic, CI/CD as a service, because I think the days of roll your own. No. Hear me out. I mean, in the olden days, every department would have their own CI/CD toolchain, which comes at a cost, of course. But if I take a look at the market, and yes, Martin, it may be to some extent maybe marketing, but and you see this across the industry, where actually you have LOBs sprouting, where these LOBs as in lines of business do nothing else than building up a service provision with a standardized CI/CD toolchain that can then be used by anybody using.
You're talking about platform engineering, aren't you?
I'm talking about platform standardization, exactly. Yeah. Where CI/CD functionality is offered as a service to anybody developing software in an enterprise. Because you're talking about standards, lowering costs, and all the rest of it.
Yeah. So this is kind of one of the typical cycles, right? Where it used to be, everything is controlled by your IT department. Let's decentralize everything and do it all ourselves. And then, let's bring it all together because it's cheaper and more efficient.
I mean, somebody very high up would have taken a look at the costs and then decided, okay, similar to platform, I wouldn't say engineering, but platform control rather, as in, for example, if every LOB under the sun, as in every department would have their own cloud, the cost would be spiraling out of control. So about 5 to 10 years ago, when this cloud dust had settled somewhat, somebody very high up the food chain said, now look, we're going to focus on 2 or 3 hyperscalers in terms of a multi-cloud strategy, and thus trying to control the costs associated with cloud deployments in a very central way. And this is basically how this FinOps approach to hyperscaler deployments and all the rest of it came into existence, in terms of somebody in controlling or someplace else said, now look, before you take out another subscription or resource group in Azure or what have you, as in name your typical hyperscaler deployment, you're going to talk to us first, because you won't get any approval without doing this. So somebody in the enterprise had a very keen eye on costs. And I see the similar vein when it comes down to CI/CD offerings in an enterprise, because normally these CI/CD workloads would be associated with hyperscaler deployments, as in you do it on somebody else's computer, and thus the cost aspect.
Well, I mean, yes. Probably the majority are doing this in someone else's computer, but there's a whole bunch of organizations doing this still in-house as well, right?
It depends on use case. Sometimes you can't do it on somebody else's computer because of regulatory requirements, for example. But even then, they would be looking at, and that goes actually back to my Redis days. I can't, of course, name any details, but I was talking to a very large service provider here in the IT space for the financial service industry, and you're talking about a service provider serving more than 20,000 banks in Germany with the associated core banking system on the rest of it, and they had exactly implemented that approach about 7 years ago already at that stage. So anything entering production would have to go through that gate, would have to go through that FinOps group being approved. Simple as that. And they would have checks and balances on container deployments, Kubernetes, the clouds, you name it. They were pretty advanced at that stage.
Yeah, I mean, there's obviously people that started earlier than others, but yeah.
Anything else we should mention when it comes down to the future? Of course, people, these are predictions, so they may be right or may be right, depending.
Oh, I don't know, actually. We never looked at our predictions before. In retrospect.
Okay.
Maybe do that, see how good they are.
Another topic, of course, and then we're probably going to finish this off, is security and reproducibility, as in sign build, for example, in terms of that you can actually make sure that nothing enters, and that goes back to your SBOM and your security aspects, that nothing goes into your builds from a ICD perspective that you haven't vetted, that you haven't verified yet. And reproducible builds would be just one approach where you basically can verify, can prove that if you throw together a bunch of components, and I'm simplifying things, of course, if you throw together a bunch of components, that they give you the same executable on a reproducible basis. Because that would allow security to be improved before you deploy it.
Yeah, that's sensible.
Okay. Time for the boxes, Martin.
The boxes. Yes.
If we have any.
We always have boxes, don't we?
Sometimes we do, sometimes we don't. Some
okay.
What's your box then?
It's a good question. Yes, my box is, in fact, snow.
Like Edward Snow?
Snowden? No. Edward Snow?
Sorry, that was Snowden.
Yes. I don't know who Edward Snow is. I don't know. But yeah. No, the white stuff.
That's okay.
Yeah.
Why is that a box?
Well, because it's really nice.
Is it now?
Because everything becomes...
You can have snow. I mean, you can have snow every single month of the year if you live in the right geography.
That's
most
true.
of the months. True. Yes.
Yes, but then you'd also have to put up with the cold and the greyness.
Martin is only
occasional snow is good. Yes.
Okay. So once in a blue moon or something like that. Okay.
Yeah, ideally in winter. Yeah.
So how much snow did you get then in the UK?
It depends where, really, but yes. Quite a bit.
Martin is living somewhere, without giving away too much, Martin is living in the central UK. And apparently it did snow there.
It did.
Which is a rare occurrence.
Yeah, last one was like 5 years ago, I think. So.
Exactly. So Martin showers and brings out the slew and just takes a couple of ride on the hill in the backyard, I suppose, just in case. With the dogs or without them. Yeah. Exactly. Yeah. Which nicely leads us to my pox, which is actually anti-pox, and it's called snow. Exactly. I hate this stuff.
Is this because of your cycling, is it?
Every now and then, yes. Germany gets hit with severe snowstorms and snow and really harsh winter conditions. And then snow is just not for me because you can't cycle. It's hard, it's cold, it's harsh, and it's miserable.
Well, you could walk. If you can cycle somewhere, you can walk somewhere else.
What's the point?
Oh, it's
cycling is
exercise for free, and you don't have to carry your bike with you.
Well, I mean, cycling is just way quicker and more efficient.
And you don't get run over or something. It's just definitely better.
I mean, I haven't managed so far. So
haven't managed what? Sorry.
So I have managed so far not to get run over.
Good.
Yes.
That's here, yes.
So Snow, if you're listening to this, stay away. At least from central Germany.
Fair enough. Central? Okay. You're not in the center, are you?
Oh, I am.
Is that called central Germany? Okay.
Yes.
Fair enough. I thought Berlin was in the middle.
So.
But anyway.
No.
What do I know?
No. Berlin is actually in a quiet part of Germany and it's in the east.
Well,
yes.
Depends when. But anyway, never mind. It's fine.
We're talking about the current shape of the country. We're not talking about kind of pre-World War I stuff.
Well, but there's a whole bit to the east of Berlin now, isn't there?
About what, 5 miles?
No. The whole of eastern Germany.
Yes, it's about what? I may stand corrected, but I reckon there's not much more than about 50 miles between Berlin and something called Frankfurt Oder, which actually is a border town bordering on Poland.
Okay, there you go. That's how much I know about German geography.
That's been sorted then. Okay, and with that, thank you for listening.
Yes.
And speak to you soon.
This is the Linux In-Laws.
You come for the knowledge,
but stay for the madness.
Thank you for listening.
We hope you liked this feature presentation. If so, please spread the word. If not, please let us know. Feedback at linuxinlaws.eu.